Today's lesson is on graphic representation. Media, businesses, and other groups are often guilty of taking data and displaying it in such a way so that it tells the story that they want it to tell. So, example. Shaylin surveys students about their favorite fast food restaurants. She presents her findings with the bar graph below. Now, of course, when we take a look at this bar graph, we would assume that nobody liked A&W. Very like only a small number of people liked A&W. A medium amount like KFC, and a huge amount like McDonald's. Now, is that true based on what the numbers are? No. The numbers are a lot closer than the graph would make it look like. So why is the graph misleading? It's misleading because it appears as if a clear majority prefer McDonald's. And just so we're clear here, I'm not saying that McDonald's isn't the most popular restaurant in the survey. It is. It's got the highest bar, so of course it is. But what the graph makes it look like is it's like a runaway winner. It looks like it's a runaway winner, when in fact it's a lot closer than that. If you're not sure, redraw the graph without the bias, okay? So we see the numbers go up to almost 50, so we'll go up to 52. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 grid squares. It doesn't get quite up to 50, so that means we're going to make every grid square worth 5. So every 2 grid squares would be worth 10. Okay? So is it number of students? Yeah, it's number of students. Okay? So the key is we're starting the scale at 0. That was not done on the previous graph. And now down here, we're going to have restaurants. This is a bar graph, so your bars should be separated. I will highlight it. I don't want you to highlight it or anything, but I'm just highlighting it so you know where I'm going to put the bars. I'm going to put the bar right here for McDonald's. The bar right here for A&W. And the bar right here for, what other restaurant is there? KFC. Okay. So I'm just showing you where I'm going to put those bars just so you know. I mean, you could put them in different spots too. It's not like you have to put them where I do. As long as they're equally spaced and they're separated, it really does not matter where you put those bars. But we can put the labels down. Of course, that would be McDonald's, A&W, and Kentucky Fried Chicken. Now, how many people like McDonald's? Now, we can't tell exactly, but we should be able to get pretty close. What do you think? What's that number for McDonald's? Is it closer to 45 or 50?
45, 50.
I think 50. So therefore, it should be what?
47, 48.
Well, it shouldn't be 47 would be closer to 45. So 48 would probably be the right answer. And it's not super close to 50, so I think it's 48. So let's draw a bar up to 48. So what would that look like? That would look like probably something like this. Nope. I don't even know what I'm doing. Let's try that again. This time I'm going to select a rectangle. There we go. There's McDonald's going up to about 48. Okay?
But again, maybe take away the ruler.
Yeah, rulers do help. You think that's 26?
26.
That sounds reasonable. Yeah. So, let's go ahead and make a go up 26, which is Right was here. There we go. And KFC hits 35. We should probably add a title, which would just be favorite fast food. By starting starting at 0 right here, we remove the bias and the bars are representative. The KFC bar especially is much closer to the McDonald's bar than was previously reported. Like it looked like before, the McDonald's bar was at least twice as big, where we can see the number of people that prefer McDonald's is not twice as big as the number of people that prefer KFC. Okay? So that's a way to exaggerate the differences between those three restaurants.
I believe we're getting a phone call.
I am. That's okay. Next example. A hockey player is negotiating their contract and states that they score goals at a very consistent rate. They use this graph to support their cause or their case. See, here's the graph. And if we look at the graph, it does look... So what does consistent mean in terms of numbers? Well, let's say you come into a math class, and you know how we have quizzes.
Come to my place?
No, I was not going to say that. If you come into my, if you,
Like you're gonna say that.
no, I was not. I was going to talk about math class. So, if you are a math student, and let's say you get 9 out of 10 on the quiz, 8 out of 10 on the quiz, 9 out of 10, 8 out of 10, 8 out of 10, 9 out of 10, 8 out of 10, 9 out of 10. Those numbers are very close together. So, what we can see is, if you got these marks on a quiz, these marks are very close together. So that means that they're very consistent with regard to one another. They're close together, okay? They're close together, all right? So when we talk about consistency in terms of this example, we're going to be testing to see if these numbers are close together. And what we can see is, well, it goes from this much to this much. That's not very big of a drop. And it goes from this much to this much. Well, that's not very big of a jump. And then we go from here down to here. That's not a very big drop. So those numbers seem pretty consistent, right? Well, maybe not. So why is the graph misleading? Well, it's misleading because here's the difference. In this graph, like what are these actual numbers? Like what are they? Like let's ballpark it here. This is probably, I don't know, 22. This is probably, I don't know, 18. This appears to be like 27. This appears to be 15. Ooh, now all of a sudden those numbers don't look very close together. Like, they're not like hugely different, but they're a lot further apart than maybe we thought they were. As a matter of fact, the highest number is almost twice as much as the lowest number. So there is a significant difference between those numbers. So why did our eyes get tricked by this? The reason why our eyes got tricked by this is because the top number is way bigger than the top number there. Like, if the highest number is 27, then ideally our highest number here should be just a little bit more than the highest number. So what would be a good highest number here? Not 60, but what? 30. 30 is a nice even number, and we should go up to 30 instead. Okay, So the graph is misleading because the scale goes to a really
Big number.
large number, and the last graph exaggerated the difference between the numbers. In this case, it does the opposite. It makes the numbers closer than they appear. So again, the scale goes to a really large number and it makes the numbers closer than they appear. So redraw the graph without bias. So I did write those numbers down, 22, 18. So I'm just going to redraw them down here just so we have them. 22, and I don't have to keep going back. 18, 27, and 15. And that was for 16, 17, 18. Oh, and there's actually that last one that I didn't even think about before. The last one at 2020 is, what we say that would be. That'd probably be about 23. Yeah, 23. So 23. Okay, so we're going to use those to draw our graph. Now again, the highest number is about 27, so our scale should go no higher than 30. And so that means that every grid square will be worth 3. And how do we know that? We know we're going to go up to 30, and we divide it by the number of grid squares, so that gives us 3. That tells us that every grid square goes up by 3. You don't have to write every number down because that gets a little repetitive. So we'll write every second number down. So that's 3, 6. Should write that down. 9, 12. Write that down. 15, 18. Write that down. Oopsies. I said 18, but I wrote a 15. And then we'll go 21, 24. Write that down. And of course, we end up at 30. Now, what do these numbers represent? Well, these numbers represent goals. And we're doing this as like a line graph. So this is we're talking about years here.
What is that? 124?
This is 24. It doesn't really matter how we do this as long as they're separated. There's 5 years here. You know, I guess I'm probably just going to say something like this. Like start right here. This is 16, 17, 18, 19, and 20. And we're just going to put dots at each one and we're going to connect them. So 22 would be like right here. 18 would be right here. 27 would be right up here. 15 would be a little bit down right here. And then 23 would be right here. And then it's just a matter of taking a ruler and connecting these dots with the straight line to get that nice looking line graph. And of course, we do need a label along the bottom, so the bottom is going to be the year. And title for the graph is Goals by Hockey Player, so we'll write the same title up here, Goals by Hockey Player. Okay, so I just want to put a bow on this before we call it a lesson. Like, we can clearly see the difference between these two graphs. If we look at the graph above, there's not a lot of difference between the numbers. They look like they're very close. But when we look at the unbiased graph down here, we can see there's significant differences between the numbers. And those differences were minimized by changing the top number for your scale and making it really big. So by doing that, it makes the numbers look a lot closer than they ought to be. And in the last example, what we did was we started at a number close to the bottom number, not 0. And what that does is the opposite. Instead of minimizing the differences between the numbers, that maximized the differences between the number of people who preferred McDonald's, A&W, or KFC. So we can really kind of accomplish either of those two things by changing the scale. Now, in your assignment, they will touch on a couple of things that are even other ways of doing it, but these are the main ones that you need to kind of watch out for.